Good afternoon, everyone. Thank you for joining us. My name is Marissa Waterman. I'm the Marketing Director here at the Academy. Today's webinar is titled Don't Waste a Drop, How Tech Helps Santa Monica Identify Where and When to Expand Reuse. Our Executive Director, Dr. Daniel Other, will serve as the moderator and will introduce our speakers today. During the presentation, you'll be able to submit a question by clicking on the Q&A icon on the bottom of your screen. We'll do our best to address each question at the end of the presentation. Before we get started, Dr. Other would like to say a few words. Dan, how are you today?
Fantastic. Thanks, Marissa. I really appreciate that. So welcome everyone who's joining us today. As many of you already know, Academy programs often are free to our members. The goal of our programs is pretty simple. We want to grow, connect, and diversify the environmental profession, and today's webinar is an opportunity to do that. One way the Academy grows, connects, and diversify is by recognizing amazing work. And today we have a webinar that is all about an award-winning project, and I'm so excited to be able to share it with you. As we begin, I'd like to say a special thank you to our patrons. Patrons are organizations who see benefit in the work of the Academy, and to ensure the success of that work, patrons provide us with much needed financial support. So thank you to the Academy patrons whose logos appear on the slide right now. As a reminder, webinars are offered by the Academy are vetted by a team of experts who offer feedback on subject content and ensure that every webinar is of value to our members. If you've got ideas for future webinars, please let us know. We're always on the lookout for great content to share. As I've already mentioned, today's webinar is an award-winning project. Specifically, we're going to hear from the 2024 winner of our grand prize in the planning category for the annual Excellence in Environmental Engineering and Science competition. And here come on our speakers. So back in April, President Wirt and I had the pleasure of introducing this award-winning project for recognition. And today I have the added privilege of moderating this fantastic webinar, and I'm so excited to hear about this. So our speakers are Dawn Tafler, who's a vice president with Kennedy Jenks and the engineer in charge for the Santa Monica project, about which we'll hear a lot of detail. Also joining us is Alex Waite, a senior civil engineer for the city of Santa Monica. Dawn has been an active member of Water Reuse California for over 20 years. She holds a baccalaureate degree from the University of Illinois and a master's from Berkeley. Alex oversees the design, construction, and optimization of Santa Monica's Water Resources Division. He holds a baccalaureate and a master's degree from the University of Southern California. Today, we'll be hearing some details about how Kennedy Jenks work collaboratively with the city's planning, engineering, and operations personnel. I'm really excited to hear some details of this innovative GIS system, and I'm really curious about this concept of radius of cost effectiveness. So as a reminder to everyone, please place your questions in the QA function. I'll be reading them throughout the webinar, and I'll try to address as many of them as we can as part of a moderated discussion at the end of this webinar. Dawn and Alex, we are so excited to learn more from you. The stage is yours.
All right. Thank you, Daniel and Marissa. I wanted to start out by thanking the Academy of Engineering and Environmental Engineers for recognizing this project for the Grand Prize Award in Planning. It was developed with my colleagues and I at Kennedy Jenks in collaboration with the city and led by Alex, who's here today to present with me. The Recycled Water Master Plan really provides a balanced portfolio to optimize irrigation, a non-potable reuse expansion, while also navigating these newer uses of recycled water for potable purposes. Really, the point is to make sure no drop of water goes to waste. But it's more than a roadmap. It's a precedence for the innovation and sustainable commitments of the city, and it's really a testament to the city's development of a sustainable future. So with that, Alex is going to kick off the presentation today. He's going to start off with an overview of the city's path to sustainability. I'm going to get into a little of the details of the Recycled Water Master Plan approach. And then Alex is going to wrap it up, covering some of the financial implications and the key takeaways. So with that, Alex.
All right. Thank you, Dawn, and thank you, Daniel, for that introduction. So a little bit about the city of Santa Monica. Oh, there we go. All right, so the city of Santa Monica, we're a small coastal city about 9 square miles located in Southern California. We're actually surrounded on 3 sides by the city of Los Angeles and on the west side by the Pacific Ocean. So the city serves about 93,000 residents, providing drinking water, wastewater, and recycled water services. Back in 2018, the city updated the Sustainable Water Master Plan to find ways for the city to become resilient and self-sufficient on local water supplies and get off of imported and costly water supplies from the Colorado River and Northern California. And so part of this master plan, we were able to identify ways to create this diverse and sustainable water supply to support the community of Santa Monica, reduce the energy footprint, as well as find long-term cost benefits for ratepayers. And so before going into that master plan, I do want to touch on the various ways that recycled water is utilized throughout California as well as the country. And so this is kind of the closed loop system of potable reuse, showing the multi-barriers that are specific to California, but utilized throughout the world in terms of potable reuse projects. And so for Santa Monica, we've been doing tertiary treatment on stormwater for non-potable sources for that unrestricted irrigation and indoor use. But now we've gone beyond that in some of our projects that I'm talking about today to do the groundwater replenishment side. And with regulations that are now complete in places like Colorado and California, we now have drinking water regulations, both with a raw water augmentation as well as with a treated water augmentation. So there's so many different pathways to utilize advanced treated recycled water for lots of different applications. And that's what we were really investigating as part of this master plan, is what's the best use for this water. Here's a figure of the city's water supply schematic. This is circa about earlier this year as we start wrapping up some of these projects. But this is really an open system. We're taking imported water from Metropolitan Water District of Southern California. We're utilizing that throughout the city and then discharging our wastewater to the City of Los Angeles' Hyperion Water Reclamation Plant. As I mentioned, we did have a small amount of recycled water that was coming from our Santa Monica Urban Runoff Recycling Facility, or SMRF. And then we also had local groundwater supplies from our 2 local well fields. But as part of the Sustainable Water Master Plan, we identified 3 different components of how the city could become self-sufficient on those local water supplies. So first and foremost is conservation, just reducing the overall amount of potable water that's used in the first place. Component 2 is looking at advanced treated recycled water, how to utilize that water for both non-potable applications, as well as for augmenting our local groundwater supply. And then number 3 is how to become more efficient on our local groundwater supplies. So remediating contaminated groundwater, as well as expanding the efficiency of our existing local groundwater treatment systems to produce more water from the same raw groundwater sources. So on that second component, the alternative water supply, this is part of our sustainable water infrastructure projects. So there was 2 facilities that are incorporated as part of this project. There's the advanced water treatment facility, as well as upgrades to the existing Santa Monica Urban Runoff Recycling Facility. So the AWTF is able to take 2 source waters, so wastewater, as well as a blend of stormwater and urban runoff. So most of the time it can do 100% wastewater, and when there is stormwater available, can take up to 30% of that stormwater supply, runs it through a full advanced treatment facility to take that water up to the Title 22 standards for the California Code of Regulations for groundwater augmentation. And then for the SMRF, it's able to take a blend of stormwater, urban runoff, as well as brackish groundwater, runs it through an advanced treatment process consisting of reverse osmosis and creating what's called the Title 22 diluent water source under the California Code of Regulations. So these 2 facilities together can produce 1.5 million gallons per day of advanced treated recycled water, both for irrigation, dual plumbing, as well as for groundwater recharge. Now you may be looking at this and like, Alex, this is a parking lot. I'm not seeing the Sustainable Water Infrastructure Project. Well, the SWIP is actually located below the parking lot surface. So this is actually the first advanced water treatment facility in California to be constructed completely below the ground surface. But we ran into a challenge here with SWIP. We have the ability to create a lot of water, right? Almost 1,700 acre feet per year of advanced treated recycled water supply. But our current use for non-potable is less than 100 acre feet per year currently. So we have a lot of supply left. So what do we do with all that supply? What are our options? Maybe there's non-potable uses. So here's a figure of our existing non-potable system. So it's about 4 miles of existing what's quote unquote purple pipe system. So serving for non-potable irrigation and dual plumbing customers. We have 20 existing customers and 4 of those are private customers. Now there are additional administrative requirements for these non-potable systems. So there's requirements for on-site supervisors, as well as additional documentation with LA County, as well as the Regional Water Quality Control Board and Division of Drinking Water. So the problem with this system is that new pipe equals more money, right? And so that's something that we need to evaluate as part of this plan. So what about groundwater recharge? We know this water meets those groundwater recharge requirements, so maybe we can target that. The existing groundwater injection well that was constructed, that's our SM10I well, and you can see a figure of the decorative sign in the bottom right-hand corner. This well was designed to target the lower aquifer zones in our Olympic well field. The rationale being is that the upper zones were contaminated with historical industrial contamination. It's being treated through that component 3 that I mentioned earlier. So in the modeling effort for this project, we modeled a capacity of 400 gallons per minute. Now, unfortunately, when we actually drilled the well and started doing injection testing, we found that the geology in this area actually creates a pinching effect. And you can see it in the figure there where the aquifer zones are actually coming together towards the edge of the well field. So this actually limited our available capacity in this area to about 200 GPM. And due to the separation requirements between a production well and a recharge well, we couldn't actually put the recharge wells any closer to the production wells. So that's a big challenge in order to put in more groundwater injection wells at this same capacity. So what does that mean? In more money, right? Well, what about the last piece? What about direct potable reuse? Is that possible? So this is a schematic of a concept that we've been working on in the city of Santa Monica of how to take all these pieces that we have and put them together, taking the SWIP advanced water treatment facility, the SMRF, also our drinking water system, so our new Olympic advanced water treatment facility, which consists of UVAOP and GAC, as well as our existing groundwater desalter facility, the Arcadia water treatment plant. So is there a way to put these pieces together with potentially a new pump station, maybe a flow control valve, perhaps additional treatment to meet the new DPR requirements that were approved by California in December of last year? So this is another opportunity that we were looking at. So why a master plan? Well, it's the plan for all these capital investments to utilize all the recycled water that's available, so no drops are wasted. So looking at that expansion of the non-potable system for those additional applications, expanding indirect potable reuse, seeing if the groundwater replenishment and more wells is feasible, and then finally exploring the direct potable reuse opportunities. So now I'm going to turn it over to Don to talk through the rest of the master plan effort.
Fantastic. Thanks, Alex. Alex really set the stage here of all the great work that the city has done. And it's a little bit different. Most master plans start out when cities and agencies don't have any infrastructure in place. They're starting to figure out what are we going to build so that we can start to meet these demands or beneficially reuse our resource or avoid discharging because of regulatory requirements. So this is a little backwards. It was a unique plan for us to work on in terms of recycled water master planning. So what this was really about was connecting the dots between the city's existing systems, the ones there, we're just building, the ones in constructions, and then the new facilities, all aimed at reducing the city's reliance on imported water supplies. So as I started off saying, this is a roadmap to optimize the use of the city's resources in the best way, that 1,600 acre foot Alex mentioned, in a way that is cost effective, and also thinking about maybe some of the longer term regional opportunities. So the overall approach is really a 4-step process. The first step sets the boundary conditions. You got to figure out really knowing what those available supplies are, not only on an annual basis, but if there's any variation, thinking about the reuse opportunities, the non-potable and potable, and what those demands are. Then you got to think about the customers. Who is going to be the customers that are really we're going to target? Where are we going to send this new conveyance? What's the best bang for our buck in sending it out there to meet the demands? Who are the priority customers? And then that comes back into cost effectiveness. And you can see this was an iterative process, right? Because you're like, oh, we want to serve everyone. Oh, it's too expensive. What if we serve some? What is served this group. And so we use GIS to help us model and facilitate a very transparent and justifiable cost approach. And then finally, the last step was evaluating projects, putting together portfolios. There's not a lot of low-hanging fruit out there anymore. There's no one option that does everything. So it's really about looking at the best diversified portfolio supply and then creating a capital improvement plan so that the city can budget, seek grants and funding, and then have a plan to design and construct facilities. So let's dive into the details of step one, defining potential customers and demands. So you saw that the map Alex first presented, that was the baseline system. Purple pipe in the middle is the existing system. The blue dots here show all the potential customers in the city for non-potable reuse. A market assessment is basically just looking at, well, what's the market? Who can we sell this water to? And we really did this market assessment in two parts. This first part was this non-potable approach, looking at who would use the water for irrigation of landscapes, parks, maybe a golf course, a cemetery, but also dual plumbing for indoor use. The city is really committed to reducing water demands into the future. And so new developments are being asked to do dual plumbing, which means a separate set of pipes inside the buildings to allow non-potable recycled water for flushing toilets and other non-potable uses. So that's only for future customers. So these blue dots represent all of those together. So there's a lot of dots. They're spread all over the place. I'm sure all of you are going back to that number of like, oh, that's a lot of cost if you're going to connect every single customers. So first we wanted to look at what are those demands so we could start to think about what are the best customers to connect. The next step in the potable reuse market assessment, we started looking at these other uses that would require, that benefit from this very high level of treatment that the city is doing. Indirect potable reuse for groundwater, you can see that these are the little pink triangles. Some of the locations where Alex was talking about earlier in the Olympic area, it's kind of in the middle of the map there. And then also expanded reuse, some of the new wells that Alex mentioned would be in that area. And then direct potable reuse is just outside of the city boundaries. I know it's a small label there, but it's a big pinkish box that says Arcadia Water Treatment Plant. That's where the city already treats some groundwater coming out of their basin, and that is where the direct potable reuse water would be blended in there. And then it could be distributed to all the customers that are connected to the city's potable water system. So this is a figure that's showing all of the different potential demands. And what we're trying to see is, well, if we served everyone, do we have enough supply? And as the title indicates, this really revealed that the city is supply limited. But just to walk through it a little, that gray, the bottom bars at the bottom are the current customers. As Alex showed in that first slide, there's some customers hooked up receiving the water from the SMRF, the stormwater project, but it's a very small demand, right? These are shown in monthly acre foot per month values. We started to add on top of that all of the different demands, starting with non-potable reuse. The existing customers are parks that are already using water that we could just convert. The future customers include future developments, their irrigation, their dual plumbing. And then you get into the green bars are the groundwater replenishment, both the initial wells that the city is in planning, but also the potential to expand, and then direct potable reuse demands. Now, the horizontal red line is the important ones here because this is the maximum supply capacity that the city will have when running all their new facilities at full capacity. That's at 1,600 acre foot a year, Alex pointed to. We'll keep coming back to that. And as is very clear, if you serve all of these demands, you're not going to be able to have enough supply, right? You're going to have to, figure out who gets what water, and there's no point in building a bunch of infrastructure they can't serve. So this really indicated the need to identify the best portfolio of customers, right? Because you're not going to connect every single blue dot in the picture. So this leads into step two, getting into anchor customers. Now, what's an anchor customer? An anchor customer is really, the customer that's going to have the biggest priority. It's the biggest bang for your buck, maybe, or it's the most visible customer. And so what the city really wanted to do is they wanted to prioritize customers that are important to the city. And most of those were either parks and green spaces shown by the green dots, or some of the bigger future developments. There's one future development in the southeast side of the city there, that's at the Santa Monica Airport, which is going to go through a redevelopment phase in the next couple of decades. That's going to really be an opportunity to create more demands and develop that park sustainably. So they wanted to think about it in the future. They said, well, we want to plan in a way that's going to help us to meet our other goals. And so these anchor customers really help define the geographic direction of expansion. So when we started to look at these anchor customers, we started to group them into different areas. And using a simple ABCD system, you can see here that there were 5 proposed backbone extension. And that kind of means that's the bigger pipe. And the intent is we want to deliver water to these priority sites. And then we'll think about what are the smaller customers that we serve on the way. So we had a center, A is in the center of the city. It's kind of where a lot of the new future developments would be. B is out there where that airport would be, and there's a few big parks. C is the lovely Santa Monica coastline. There's some nice parks there. If you ever come to visit the city, I highly recommend it. D, there's a median out there, and it's used by a lot of city residents for running and biking up the path. And so there's a small demand out there, but the city was interested in serving that. And then E is another big development that could come in the future that would have some demands. So here's all the blue dots and how they fill into there. So you can again see, well, A is going to have a lot more potential for some of these future buildings that are going to use recycled water, less development in the outskirts of the area. But all of this was taken into consideration and really came to the need for a very transparent approach and maybe a more quantitative approach to figure out, well, how are we going to figure out what customers to connect? So here's we get into the radius of cost effectiveness approach. And this was a way that we used to compare costs. So radius of cost effectiveness is essentially looking at a way to quantify the distance at which potential customer can be cost effectively connected to a recycled water pipeline. So it's a way of a relative comparison and looking at key parameters. And we did this using an equation that is focused on the customer's demand, because obviously more demand is going to be a benefit to beneficial reuse. And we compared non-potable reuse expansion and DPR delivery. So the idea is, does it make more sense to connect this customer with a pipeline, a purple pipeline that serves non-potable water specifically for non-potable reuse? Or does it make sense to send that water to the direct potable reuse system and use that water that would get there eventually after going up to the Arcadia treatment plant, coming back in the drinking water distribution system? So this is very unique. Not most cities wouldn't have the opportunity to look at these 2 different ways of serving a customer. And it is the same water, both of them very high quality. So we compared a cost comparison. We looked at the demand and what the dollar per acre foot cost would be to send that water into the through direct potable reuse. So there's some infrastructure associated with that, and then how it's delivered. And we compared that with the cost of a new pipeline to connect that customer to the non-potable irrigation system, to one of the backbones that we identified as part of the customer prioritization. So the pipeline length ended up being the radius that we looked at to see how far that customer is from a backbone would indicate whether that customer is cost effective. And you're probably turning your heads like, well, how does that work visually? Well, I'm going to show you. So when we looked at customer A and B, customer A is on this map here in the kind of the northwest side, and customer B is on the southwest side. We did the equations for each of these to look at whether or not the radius of cost effectiveness would come into contact with the nearest transmission pipeline, backbone pipeline, or existing pipeline. So customer A had a smaller demand, so it has a smaller radius and a smaller circle. It's shown here in red because that circle, that radius, does not come into contact with any of the existing, the purple, or the proposed, the pink dashed lines. So basically that's saying it wouldn't be cost effective to serve that customer. It would be more cost effective to serve that customer through potable reuse through a DPR project. Customer B, on the other hand, was a larger demand customer, and it was also nearer to one of the extensions. And I think this was the extension B. So shown in green here, that radius intersects with one of the existing pipelines, and so it would make sense to serve that customer directly from the non-potable system. There you go. So we were able to, using GIS, run this for every single dot on the map. And you'll see here a lot of those blue circles, when there were so many of them in that area A, right in the downtown area where they're doing all this development. Well, non-potable reuse for dual plumbing has a relatively small demand. I mean, it's flushing toilets. It's not the kind of thirst that our grass has for water. So a lot of those customers were relatively small demand, small circle, and therefore they don't intersect with a planned transmission pipeline, and therefore they're not cost effective. You can see here the bigger circles, now highlighted in green, show that when you have a much larger demand, those are going to be much more cost effective to serve. So now you can start to see, oh, if I gave this to my 6-year-old kid and said, connect the green circles, you'd start to draw those lines and you'd start to be able to see how would we find a cost effective recycled water expansion system. So now that we started to do all this, of course, still an iterative process, going back and forth, we're like, okay, well, how are we going to really compare different portfolios? First, we looked at the non-potable reuse projects, just looking at those 5 backbone areas, A through E. And we said, all right, what would be the cost to build just that pink dashed line? That's that backbone pipeline. And how much recycled water would be served? So no surprise here, A had a lot of recycled water customers, but it also needed quite a bit of pipeline. So A had one of the highest capital costs, shown by the first bar, but also had a pretty high amount of recycled water delivered, which is the purple dot. Remember how I talked about D, that faraway customer that was a median? Well, it has the lowest capital cost because it's only one pipeline expansion, but it's only irrigating that median. So it's a really low recycled water demand. So we looked at that because what we wanted to figure out is, well, we don't want to expand in every single area. We want to figure out what's the backbone area that we want to expand in. So a good way to look at this is looking at the annualized capital cost. So that takes the capital cost and using an interest rate and a lifetime of the facility, says, well, how much is this going to be on a dollar per acre foot basis for the life of the project? Now the bars really tilt, right? So A was the most expensive, but because you have the greatest demand, you actually have one of the lower dollar per acre foot costs for serving that water. Versus D, that isolated pipeline out on the west side, because you're serving such a small demand, it's actually the highest capital cost of service. So basically, cost effectiveness is saying we want to serve that medium, but we have to recognize that that's going to be the highest cost to serve. Now, that is okay if that is still a priority of the city, but we just wanted to help the city to go through that process and how to then be able to discuss this with their community. So now we know that we have certain areas we want to focus on. We have a way to figure out which smaller customers connect. How do we create the best portfolio to use that 1,600 acre foot in the smartest way? So we looked at different portfolio concepts. The first one here was about maximizing non-potable reuse, maximizing groundwater replenishment. But if you do that, there's no DPR. There's no water left. You know, those were those bottom bars in the chart, and you're going to hit that red line. You're going to say, okay, we're just not going to do DPR. Maybe that's better. Maybe we're not ready for DPR. We looked at that. The portfolio concepts 2, 3, and 4 were like, okay, well, maybe we prioritize some NPR. We do as much groundwater replenishment. Maybe we do some DPR. Maybe we start to put our toe in the water there, and maybe that's a good idea. And then portfolio concepts 4 and 5, we start saying, well, what if we do more potable reuse? Portfolio concept 5 is like, maybe we should really balance groundwater replenishment and DPR together while hitting those priority customers, because we think that's going to be the best diversification and visibility. So this was an iterative process with city leadership. We worked with their sustainability group. We wanted to make sure that this would be supported by the community. And that really helped us to take this next step of evaluation of cost. Now, this is the same approach I talked about in the backbone. This is looking at each portfolio, and of course, there's sub-portfolios for each of these. So I know it's hard to see, but there is portfolios 1 through 5, and then sub-alternatives, looking again at the cost. And really the key here is If they maximize NPR, which is the non-potable reuse irrigation system, try to connect as many customers as possible, no surprise, that's the most expensive. That's that first bar. But if they maximize groundwater replenishment and DPR, so they did more potable reuse, that requires less infrastructure, those had the lowest annual unit cost. So we started to look at this, all right, how are we going to start to use these planning level costs and annualized costs to start to figure out what's the best path for the city? Again, oh, there we go there. So we started to, based on this analysis, the city said, well, based on our values, our customers, our visibility, our innovation, we've got this high quality water. We really want to do a preferred portfolio that balances all these different types of reuse. Backbone A was very important because it expanded reuse in this main city corridor where a lot of these new buildings are coming in that they want to really promote dual plumbing. They also wanted to prioritize Backbone B because that airport redevelopment was going to be really important to the future. It was going to be a really beautiful new development. They wanted to be done in a sustainable way. And then Backbone D, the expensive one out on the west side, despite it being the least cost effective, that city median provides a high community value and good visibility. So we really wanted to press the notion that numbers don't make the decisions, people do. And so Portfolio 5 is really a selective build out of non-potable reuse with a balanced portfolio of DPR and groundwater replenishment. And if any of you look at your financial portfolio and it looks like this, that's probably a good idea. So you can see those same kind of thought processes go into master planning for recycled water. So looking at the cost for the preferred portfolio, on the left is the capital cost, where you can see that the dots represent each of the demands for recycled water delivered for non-potable, groundwater, and direct potable reuse. And then when we looked at the annualized capital cost, which is the light green at the bottom, and the annual unit O&M cost. So we dug a little deeper into the preferred portfolio to fully understand what it's going to cost on an operational basis, dollar per year cost to run this project. And so you can see here that the annual unit cost to deliver recycled water for this diversified portfolio is just under 4,000 acre foot a year, which may seem like a high cost for delivering this, but let's keep in mind, if you're not in California, the cost of imported water is very expensive now and getting more expensive in the future. So we do a lot of these studies and we look at how the cost of imported water is going to increase over the years. And there is going to be a pivotal point where the return on investment is going to benefit for the city in the long run. The city also want to think about, well, if we're really constrained on this water supply, the amount of recycled water we can personally produce, maybe we should think about regional opportunities. Regional opportunities are a really good way to identify opportunities for shared infrastructure, repurpose assets that maybe aren't being used anymore, and realize economy of scales. You know, bigger bang for your buck, you're going to get better economics. So this often involves a holistic view of multiple regional water resources and integrating each piece of the water cycle to kind of realize multiple benefits, think about the best water for the best use. And so the city has been in discussions with neighboring water and wastewater agencies to discuss these possibilities. If you know a little bit about this area, you know, LA DWP is one of the big, Los Angeles Department of Water and Power is one of the big recycled water providers and water and wastewater in the city, and they have a big water program that they're looking at doing. And so they have looked at what it would take to expand their recycled water system. So down in the green area here, you can see that they've thought about moving some of their system up north towards the city of Santa Monica. At the same time, West Basin Municipal Water District is in the southern area here. This is the blue line. That's their existing recycled water system. Interestingly, they produce designer water. They produce different water qualities depending on different reuses. They serve some really high water quality to refineries, some different water qualities for irrigation. So they also have plans to look at expanding. And one of the other projects is in this orange, it's called the Kenneth Hahn expansion problem. That's another possible project. The city of LA is also looking at a big program called Operation Next, which is looking at potable reuse. So there's a lot of different things in play. So the city is kind of keeping the doors open. The stars in the kind of northern part of the map indicate 2 potential locations that could be a key point to accept recycled water should one of these other expansion areas move forward. And maybe the city could bring in some of that water. They know they have more demands. Maybe they can bring that water and add it to their potable reuse system if it's of the right quality. Maybe that water could be used to irrigate that new airport area if it's of tertiary quality. So it's one of those longer term thought process, but really a key to a holistic planning, saying we want to make sure that we're using the best use of our regional water supply. So I'll hand it back over to Alex to talk financials.
All right. Yeah, thank you, Don. So yeah, I want to close out here looking at the financial impact if doing these projects, right? As a public agency, we have a fiscal responsibility to our ratepayers to find the most sustainable and cost-effective practices to implement these projects. And so we want to look at what are our current rates for recycled water and how does that compare to our potable water rates? And if we were to implement the preferred portfolio, what impact would that have on our ratepayers? So here's a slide showing the recycled water rates on a dollar per 100 cubic feet basis for many different agencies throughout California, trying to do that side-by-side comparison of our rates, are they at the right level compared to where some of our member or our other agencies are at. And so you can see here at the bottom, City of Santa Monica, right now we're at $3.49 per 100 cubic feet. And there's several agencies that have a higher dollar per HCF and a lower HCF, so we're kind of right in the middle. But if you compare this against our drinking water rate, and so we actually have 3 tiers, and the lowest tier is a tier 1 rate. Our recycled water rate is actually less than half of our dollar per HCF for drinking water. So that's a big disparity, right? So why do we have that disparity? Well, we're trying to recover costs through the sale of recycled water, but we also want to incentivize the use of recycled water supplies. So in some areas of the city, it is actually mandatory to use recycled water for new development, but there's other areas of the city where it's not required. And although we have identified where we want to expand the backbone, we do also want to encourage folks, developers, to use recycled water to limit the use of potable water for these things that don't really require it. But the challenge is as you have a lower recycled water sale versus drinking water, then it actually impacts our ratepayers even further. And so this is a cost allocation chart looking at that preferred portfolio that Don was showing. And we're looking at the non-potable reuse applications, the groundwater recharge applications, and direct potable reuse with the cost based off of the sales of the recycled water. And what we see here is in the direct costs, these direct costs are an annualized direct cost over a 30-year period, as well as the administrative costs for the city to actually implement these projects. And then the column shown in red, so this is actually the avoided costs from the sale of recycled water, so essentially money we're making up by selling this water, but it's also avoidance of the wastewater that is sent to the City of Los Angeles' Hyperion Water Reclamation Plant. So we actually pay Hyperion to take our wastewater. So any wastewater we don't send down the pipeline, we can actually save that money. And what we see here from the non-potable side, since our recycled water sales are so low compared to the actual cost to implement this program, it will have an impact on our ratepayers of about $2.7 million on an annual basis. Same thing with the groundwater recharge side. Now, in this case, we can actually sell that water eventually as drinking water because we're augmenting our groundwater supply. So the avoided costs are actually a little bit higher here, but it still will be an impact on our ratepayers, about $320,000 per year. But interesting enough, on the direct potable reuse side, since we have so much existing infrastructure already, and there's pretty limited infrastructure needed at this time to implement that program in the future, the avoided costs are actually much higher compared to the costs for the direct costs as well as administrative costs. And so there actually be no impact on our ratepayers on an annual basis. It's shown as a negative value there. So that's a really interesting phenomenon that we're seeing when we look at these direct potable reuse programs and how that actually, not only is it potentially more sustainable, but more cost effective than some of these other beneficial uses. So this is very reassuring when we're looking at the preferred alternatives and where we may go in this program. it is. All right. So finally, I want to close with our key takeaways and our next steps. So key takeaways here, first and foremost, is this was really interesting to find out that we were actually supply limited in our advanced treated recycled water. We thought we had all this water, but then you look at all these different options and maximizing the use over every single one, and it's actually not feasible based off the amount of water that we produce. So now we need to be a little bit more selective about how we're using that water. And so we looked at those selective non-potable reuse projects that are key to growing the sustainability of Santa Monica as a whole. And then finally is diversifying that recycled water use, finding the most sustainable practices as well as the most cost-effective to create a full supply portfolio to utilize all available water that we're able to produce. And so what are those next steps? Well, we're looking at expanding pipelines to key customers. We have several projects ongoing right now in design and will be going to construction soon to further expand the purple pipe system. We're also in the process of constructing one new groundwater recharge well that will be of relatively the same capacity as our existing well, and also in the design for a third well. And then finally, we are kicking off a feasibility analysis to further investigate direct flow reuse in what we're calling our One Water Master Plan that should be kicking off around next month. And that's actually partially funded through the U.S. Bureau of Reclamation, and hoping to have that finished by the end of next year. So very exciting work that we have going on here. And we appreciate all your time, and we're happy to take any questions.
Fantastic. Don, Alex, thank you so much. That was awesome. That was awesome. What I might suggest, maybe if we pull a slide down, because then people can see our smiling faces a little bit more. This is great. We've got some questions that have come in the Q&A panel. Just remind audience, you're more than welcome to throw some stuff in there, and I'll keep an eye on that. But let me just kind of frame a little bit out of the gate, right? So here's the questions that I saw people coming out with, questions I had from this. I'm going to run through them kind of all, and then we'll kind of come back and pick them off. So, a very high level kind of backing up, right? So one of the questions, are there any significant direct potable reuse systems already there where people are drinking direct potable reuse, right? Like, is it already there in Santa Monica? Is it already there in California at large? One of the questions people had is like, tell us what's already there. And along the lines with that, and you already touched on this some, but just to kind of elaborate, why not just join up, right? Like, Santa Monica, you started with this kind of, less than 100,000 people in this area with millions of folks. So help us understand some of that. You did touch on it from some of the cost, but how about touching on it also additionally from some of the legal, right? Like, are there pros and cons to a legal being tied up with somebody else or not in this space where people are trying to figure out this direct potable reuse? So that's kind of one. Second is then a little bit more in the particular details of the existing system there in Santa Monica. What are some of the characteristics of the wastewater that you already have, and how is that influencing, the treatment trains that you've already got in place? So without packing every last detail, folks were looking for a little bit more detail of kind of what was in those existing things. In particular, are you limiting the industry that can be there? Or are you treating some of the pollutants? Or, how are you doing some of that kind of upstream thought? SWIP is this first advanced this underground facility. Can you mention any kind of interesting challenges associated with that? Although that's not the focus here, people were kind of curious about that. And then how do we think about groundwater and the groundwater shed moving across jurisdictions, right? Because, like your pipes in the ground and the water you've got kind of on the surface is one thing, but when we're thinking about groundwater and pulling from groundwater and recharging from groundwater, how does that work with jurisdictions? One person had asked for the full system, the amortized capital operational total cost for the current capacity. And so correct me if I'm wrong, but what I heard was that there's 1,600 acre feet annually, and that right now it's looking around like $4,000 per acre foot. Those were some of the numbers I heard, but you can come back and correct those if I heard those wrong, but folks had asked in that question. With these multiple distribution systems in the ground, right? I mean, you've got the classic potable use, now you've got purple pipe. How do you avoid incorrect connections, accidental corrections? How do you supervise so that somebody didn't hook the wrong thing up to the wrong thing? Or when they make a repair on the purple pipe, they're like, oh, forget it, let's just put in a piece of blue pipe that we happen to have around. So how do you protect that in the long term? And then the one that's a little bit more tricky, which is for us as engineers and scientists, a little bit more difficult to answer, but I'd be curious your views on this. So with all this effort around the whole idea of no drop is wasted, then is it okay to kind of let people use it however they want? Like as long as they can pay for it, they can be as wasteful or unwasteful. So if you're putting all this thought process into the let's treat it as this precious thing, and then sure, we're using the transaction cost to deliver it. But if somebody's kind of making a bad choice for how they're using it, in a sense, how do you as a utility get involved in that? Or do you may perhaps not? And along those lines, how did social justice fit into this picture of who the customers were or not? And maybe the answer is it didn't because it wasn't that big a deal in our particular municipality. And then finally, a question that we regularly ask, students, future folks, what should they be studying? What should they be doing to be adequately prepared to, whether it's working for the city or working for a consultant that's supporting the city, how would they train themselves up? So those are kind of the high level to low level kind of questions. There's a lot there to unpack, but maybe we go all the way back up with all right, so what's the status of direct potable reuse system in Santa Monica or California writ large? And why not just join up or not join up in the legal consequences? Because you covered some of the cost, I believe, Don, but maybe, beyond those kind of, if you guys want to speak to that a little bit, that'd be great to start us off.
Hey, Alex, why don't I start big picture? I'll come to you
Sure.
a little more regional and diving into some of the city details, and then we'll kind of go from there.
Perfect.
So DPR was recently, the regulations were adopted at the end of 2023. Super exciting for our community. Just going back before that, we've been using recycled water for non-potable purposes in California since the 1930s. Actually, Kennedy Jenks designed the first treatment plant in San Francisco that irrigated Golden Gate Park. By the 1970s, Southern California was doing groundwater replenishment. They were worried about seawater intrusion coming in. They started to inject recycled water into the groundwater basin. It's been going on since the 70s. The groundwater replenishment regulations didn't come out until, I think it was the last 10 years, is when we actually got regulations. So they were doing this and doing it in practice, but it took that long for the regulations to catch up. Recently, there's also regulations that were allowed to put high quality purified water into drinking water reservoirs. So that is still considered what would they call an environmental buffer. That is currently not happening yet in California, but there are 3 major projects that are looking at taking purified water, putting it into reservoirs that then go into a drinking water treatment plant. So again, that multi-barrier approach. Currently, there is no direct potable reuse project in California, but there are many being planned. Santa Monica is at the forefront of this. They are really the leaders in this, and it's in part because they have all of these treatment systems. They have a drinking water treatment system in Arcadia that's using, very high quality membranes, ultraviolet light, and a lot of the pieces that provide that barrier. There is direct potable reuse project internationally. I highly recommend you go to the Water Reuse Association's website. They have a global map from Nambia that's been doing it because they had to very early on. To Texas had a few examples where they did it because they were in extreme drought. And this is what I love about humanity. We are very resilient. We do things that we have to do to survive. And, water is the most important thing. We all need to survive. So I did see a question at the end from Nader about what's the difference between direct potable reuse and recycled water. And the difference is really this treatment level, right? So it's all about the right water for the right use. When we, it started back with the Clean Water Act. We used to discharge wastewater into a stream and they say, wait a second, you're discharging it to a stream and downstream someone's drinking that water. We need to get it to a higher quality. So we started to filter it and disinfect it. Well, filtered, disinfected, recycled water can be used for non-potable reuses and irrigation of food crops in California. If you add additional treatment, you can inject that water into the groundwater basin, but in California, that's going to require you to use membranes, ultraviolet light, and advanced oxidation. If you want to put that water into a reservoir, you need to use that same system as the groundwater, but then you use the existing water in the reservoir, and you keep it retained in that natural environmental buffer. If you want to get to direct potable reuse, they have added additional treatment trains. One of the pieces is to use ozone and biologically activated carbon, or to do free chlorine. Basically, what they do is they look at log removal virus values, and they say, how are we going to get rid of all these things that we know that can affect public health? What is nice, when I saw some comments on the constituents of emerging concern, I know PFAS is out there. Membranes and ultraviolet light and advanced oxidation are very, very good at removing those constituents from the purified effluent. Now, we all have to realize that nothing is ever really destroyed. And so we do have to still look at those things in the waste stream, that brine or concentrate. But in terms of the water that is going to the public, it is of a very high quality. And that is one of the reasons it took so long for these regulations to be put into place.
Perfect. Perfect. Great answer,
Alex?
Dawn. I appreciate it. No, I love it. Alex, I don't know if you want to particularly, the angle, for Santa Monica, and maybe we covered some of the costs, but maybe some of the legal of joining up or not joining up. Are there pros and cons to that? I mean, we're none of us here are lawyers, I don't think, right? But looking on our bios and our backgrounds, but engineers and scientists still have to think about this stuff. So
Right. So, that's the interesting thing. When you look at the technical implementation, it's actually pretty simple to connect into a recycled water system. So if West Basin or LA were to drop a pipeline and say, here, take it, yeah, no problem. The challenge is actually the stakeholder engagement and getting sign off to do these things. So for example, with the city of Los Angeles, they actually have it in their charter where they're actually not allowed to sell water or recycle water to anyone else but city of LA customers.
wow.
When you look at West Basin, they're on a different path, so you can sign up as a customer and you're essentially charged just the same way as you would with Metropolitan Water District. So when looking at these large programs like LA is doing, or Metropolitan Water District, or West Basin, any of these other retailers, they're really having to go back to square one to think about their whole structure, right? To understand how they can actually serve all these different customers and think outside the box of what can I just serve to my customers versus what does the actual region need as a whole. So unfortunately, I'm giving a pretty vague answer because it's an extremely complicated process that's really going to be thought out over the next decade.
Well, I think, but what I took away to kind of pare it back from you is that the technical part can be done, but the social contracting part has got a lot of work to go. So,
Yep.
So that's helpful. So maybe if we then drill down a little bit more of these kind of there were some more what I would characterize as very specific kind of more technically questions, right? So, characteristics of some of the wastewater that was there, treatment trains to be able to deal with that, the underground facility, any special consequence, and then movement of groundwater across watersheds, right? Because I mean, you showed us the geography, and Santa Monica is not a very large place in this, much larger area. So maybe you can speak to a few of those. So characteristics of the wastewater and the treatment trains.
Absolutely. Yeah. So City of Santa Monica, so we're about 85% residential. We are about 15% commercial, very, very little industrial. So the source water that we're seeing into our sustainable water infrastructure project is very, very low in terms of those heavy metals or other industrial constituents, mostly just high in our traditional ammonia, BOD, the things that you would naturally see coming into a typical wastewater facility. So with that in mind, we have it pretty easy compared to some of our other neighbors who are taking in much more industrial constituents. So looking at that influent water quality, the treatment process utilizes fine screen first to remove those heavy particulates, branches, rags, whatever. Then we have the membrane biological removal process. We also have cartridge filtration, reverse osmosis, ultraviolet advanced oxidation, and finally chlorine disinfection. So it's a pretty robust multi-barrier treatment process to remove everything that might be in there. So a couple other notes on SWIP. This is the first facility in California to be granted log removal credits for pathogen removal from the MBR and cartridge filters. So first in the state, and then we put it under the ground. So there's a lot of interesting details around why it was put in the ground, but first and foremost is we wanted to be good neighbors. So where the facility is located, we're surrounded by Civic Center Auditorium, the Rand Corporation, our courthouse, and a childhood development center. And we're very urbanized, so finding space for a facility to be above ground is pretty much impossible. So putting it below ground was really the only step. Now, putting it below ground, for those who have designed wastewater facilities, there's a lot of safety around what can be generated through a biological process. Hydrogen sulfides and other harmful contaminants can come out and aerosolize. So we have a very robust granular activated carbon vapor phase system to scrub the air through the facility every 8 minutes. And so the facility is you can step in there, it smells great. You wouldn't even know that there's a wastewater facility down there. We also have lots of different alarms to make sure that, you know, we have the right oxygen content, we don't have hydrogen sulfide transient in the air. So a lot of additional safety factors that go into a facility that's below grade versus, you know, a typical above grade.
Makes sense. Makes sense. And then, so one quick one, again, thinking more on the hydrologic, right? So then, given residential and the value of water, do you try to tie in roof drains and all into your system to capture all that so it doesn't kind of like escape other places, or do you?
Yeah.
I'm just kind of, I'm just, it dawned on me as you were talking about it. I'm like, if every one of those drops is so precious, do you try to grab all of them when it comes from a precipitation event or not?
We sure try to. So
Okay.
on the residential side, we do have a pretty robust conservation program. So rain barrels, things like that, to make sure that residents, multi-family residents, commercial properties are able to retain as much water on site, to utilize that as a gray water system or just naturally percolate into the ground on site through a infiltration basin or a collection system. But now anything running off, let's say in an urban runoff, you're washing down your car, it ends up into the gutter. So we have several large stormwater capture tanks located throughout the city. One's located at the pier, another one is located at the Civic Center next to SWIP. So that's about 3 million gallons, and we're in the process of designing another 1.5 million gallon tank. And that would be capturing from the entire Santa Monica watershed for all the stormwater and urban runoff there. So yeah, we are trying to capture every single drop. Now, the primary driver for that is actually to improve beach water quality. So all that runoff that makes it onto the beach, it has trash, it has bacteria, heavy metals. We don't want that going on the beach, so we want to capture that first. We're taking to the next level of taking that water, treating it, and beneficially reusing it.
Makes sense. Makes sense. And then the groundwater, those
Yes,
jurisdictions of that, you know, because I mean,
that's
like
a whole
you're,
nother
yeah, because
legal
you put it in and
discussion.
it goes over there and they pull it out and it sucks away from you. And so that's got to be a
Yeah.
fascinating one for you to deal with.
So I will remark on that. So those are familiar with California. In 2014, we passed the Sustainable Groundwater Management Act, SGMA, and Santa Monica Groundwater Basin is actually made up of 5 overlying agencies. So Santa Monica, Culver City, LA County, LA DWP, LA Department of Water and Power, and Beverly Hills. And so all of these cities technically have overlying water rights. And we were deemed by, through the SGMA process, as we're a medium priority basin. So there's only so much water we can actually extract out of the ground before we have to put more in or we need to stop pumping, right? And so it's a very technical legal process that we are in the middle of, in making sure that everybody is pulling their fair share.
Fantastic. Dawn, thoughts on those questions? Those were a little bit more on the existing system ones, so
Yeah.
that's why I thought like good transition over to Alex for some of those.
Well,
But
I think tying back to your question about, well, are people going to overuse this water? You know, are we giving it to people to say, hey, wait, now you have recycled water, you can use as much as you want? And, you know, another interesting regulation passed is water conservation as a way of life. And actually, what was interesting is the recycled water community had to really work with the state board to say, look, we produce these recycled water systems at a high cost to our communities. When there comes a time when there's a drought, those using recycled water shouldn't be forced to the same sort of conservation standards that those using state water project water or Colorado River water should be, right? This is the benefit. You invested in the system so you can have resiliency and reliability. You should be able to use it. Now, of course, that doesn't mean you should waste it. Nobody's going to waste it. It's still not cheap water, even though you're doing this in the most cost effective way possible. It's hard to get out of the red. I do believe in the future, these systems will be out of the red because the cost of all the other supplies are just going up and up. And these costs should remain relatively consistent because this is reuse of a waste that is always there is a really smart way to go about your resources. What I love about your question is, as Alex said, you know, the biggest thing people think about is, well, what if you overwater the lawn and it goes out and it runs off? It's a loss. But as Alex said, they're doing the most conscientious thing possible. They're collecting all that storm water.
Right.
So if you are overwatering a lawn, that water is going to go into the storm drains and it's being captured and it's going to be treated and it's going to be reused again. I mean, you're not going to overflush your toilets inside. That really doesn't happen, you know. And then even with the groundwater basin, you know, I mean, when it's underground, we do a lot of complex groundwater modeling and hydrogeological modeling, and we look at that multiple confined and unconfined. But the truth is, we don't poke enough holes in the ground to know exactly what's going on. What's nice about Santa Monica's and their groundwater base is once you get beyond all of the different areas, that water, when you put it in, they're going to collect some of it. What they don't collect is also going to have the benefit of preventing seawater intrusion in the longer term, right? Because as long as you keep the groundwater hydrostatic pressure inland high, it's going to keep that seawater from intruding in. And we all know that can be a very serious issue for any community. And it's one of the reasons why groundwater replenishment started in California. So I think the city is really setting the stage for the most sustainable use of their resources and creating more of a closed loop cycle. And I just think it's a really exciting project. So.
No, it was it's awesome. So now, did I have the number right? It was about 4,000 per acre foot. Was that what I thought I was getting that off the slide? Was that because somebody had specifically asked for the existing? I guess the question that I read online was for the existing system. What is the amortized capital operational total cost per acre foot at current and full capacity? And I was hearing, when I was hearing that question, I was listening for it. I heard about 1,600 acre feet, and I thought I read 4,000 per acre foot. Was that is that the ballparkish numbers? Are those?
Yeah,
that's in the ballpark.
What I thought.
Right now, metropolitan water is between 1,000 and 1,500. I mean, these high level numbers. Everyone wants numbers. Nobody wants to give numbers.
Right.
My small mind, metropolitan, even some of the Bay Area imported water, you're coming in at like $1,000, $1,500 per acre foot. If you're out in Central Valley and you're doing groundwater, you can pump that water for a couple $100 an acre foot, right? You always got to think about that. But the cost curve, when you think about what it takes to take state water project water, punch it over to Tehachapi Mountains, and then Metropolitan's got their own pure water SoCal, which is going to be a very expensive but amazingly resilient, potable reuse system when that gets going. Operation Next, they have 2 digits and a B after the cost of their project.
Right.
Very high flows, so they're going to get some economy of scales, and I wouldn't be surprised if their annualized unit cost is lower. But nevertheless, as you start to balance these out, we're seeing a lot of potable reuse programs coming in that $3,000 to $6,000 per foot range. It's so dependent on what it costs to build your treatment, how much conveyance you need, how much pumping you need. But sort of that's where I like to think of things. And when you look at desal costs are in that, and somebody on here is going to love desal. It's going to be like 5,000 to 8,000 range. I mean, so we're looking at all these. Under a couple hundred is that non-available, that unicorn water. But if you don't have it now, you're never going to get it, right?
Well, you can always maybe float an iceberg down and melt it there.
I don't see numbers over 10,000. If you're seeing over 10,000 acre foot, something's not right? But that is the trajectory of the cost of water.
Okay, that's helpful. So one of now a little bit more in the kind of the down in the weedy details, right? I mean, so there's these multiple distribution systems out there. There's purple pipes. There's drinking water pipes. Okay, connections, repairs, cross connections, wrong connections. Certainly there's inspectors. I imagine for a municipality of kind of the size and what you've described, Alex, for the the kind of uses that are going on there in terms of the land use, it probably is manageable, but how do you ensure it, right? I mean, I'm sure this question is partially motivated from the fact that here in Missouri, we're digging up all of our lead service lines, and everybody's trying to figure out where are those lead service lines, right? Okay, so now you're going to have all this different kind of pipe in the ground carrying different kinds of water that you can use for different things. How do you make that work?
Yeah, it's a great question, and one that Irvine Ranch Water District really pioneered back, I believe, is in the 70s, where they pushed for their purple pipe system. And so it's really easy to visually see it as like, that pipe is purple, that is not blue, it is not gray. I know that one is different, so I shouldn't touch it, right? And so that was a really big point for recycled water to become accepted, and much easier for the community and contractors to understand the difference between these two, just on a very quick visual, purple versus blue, right? So what we take it from there is, let's say we have a developer who wants to use recycled water. There's a full permit process that goes in. We have city inspectors that walk with them to walk the site, make sure that they're tapping into the right pipe. On top of that, we are also required to have LA County Department of Public Health. There's permits that are required through them to use recycled water. They also provide their own inspection. So there's multiple layers of inspections to verify that everything is separate. And then even once that recycled water, it's tapped to the right line, it's on site, but how to make sure that your dual plumbing, your purple pipe in the house or in the multifamily is separate from regular plumbing. So again, LA County city inspectors are there reviewing all the pipes before all the drywall is up. And then they actually do a flow test with dye. They run dye through the system, just like they do with the potable water system, but they run dye through the system to make sure that the faucets that are dual plumbing are not seeing that dye versus the drinking water side. So it's a very robust checks and balances to make sure that it's all there. The last thing I'll say is that on the on-site side, every site with recycled water is required to have an on-site supervisor in California. And that on-site supervisor is responsible for the maintenance of that system and verifying that there is no, effectively a backflow prevention, right? That we're not going to see that water go back into our potable water supply.
Makes sense. Makes sense. Well, I appreciate the details of that one. So maybe if we'll pivot a little bit into the one where we started to touch on, which is this, a little bit more over to the social side, right? And you had touched on this, Dawn, where I'd kind of asked the whole like, okay, so every drop is precious, but then you sell it to people and they can, I bought it, I can use it how I want, right? So there's a part of that, but in that is a little bit of the social justice issue, right? Because not everybody, in a sense, everybody is bearing a certain part of the cost because this is a public good, right? And then people are then individually coming in with monies they have, and some people might have more money, some people might have less money. Your presentation was really clear, where it was looking about priority uses and different customers, and you're like, okay, but like you said, but people still pick this at the end of the day, and so how did those kinds of issues get baked into this if they did?
Well, and I've seen this in a few ways. So let me cover it in kind of three approaches. One, the fair share of costs, right? So you can tell from the amount of infrastructure and treatment that recycled water is actually going to be more costly than a lot of other supplies. But recycled water can benefit the whole broader area, right? So stepping outside of Santa Monica, I'm going to give an example from another area where they basically set forth a recycled water use area similar to Santa Monica's. And they said, basically, if you're in this area, you're going to be required to put in purple pipe, either to serve new developments or indoor or irrigation. And that's a cost that the developer bears, therefore it's a cost that the new developments bear, right? By doing this, you're going to get some value of, you're going to have a resilient supply that's not going to have to cut back during drought, and you're going to get a cheaper rate for that water. A lot of times recycled water rates maybe are 80% potable. If you're outside of that area, you are not being required to put in purple pipe, but you are benefiting from those that are. Therefore, those folks should pay into a development fee. So the developers there, since they don't have to build it, they pay a certain amount per unit. So the money from those developers who don't build ends up supporting the expansion of the program as a whole. So that's a really nice way to say there's a policy that says we all benefit from recycled water, therefore we all share in the cost in a way that makes most sense. Another equity picture that's kind of interesting is, the willingness of folks to take the water and not making it seem like we're giving the worst water to our most disadvantaged communities. We all know that a lot of wastewater treatment plants are in areas of disadvantaged communities, and they have to suffer. Not all of them smell as like flowers like the Santa Monica plant do. So they may have to breathe in more of these odors. And so there is a lot of conscientiousness from cities that have those social equity issues. And they want to say, well, wait a second, we got to make sure we're smart in our messaging and that we talk with the communities, because I'm going to say the toilet to tap thing doesn't go away. And I know we're not supposed to say it, but I'm kind of owning it. Like, we have to think about it, the way we are treating water is now different. Potable, purified water for potable reuse can be of a higher quality. And it usually is than the supply that's out there. Though you are still going to have the perception that it's toilet water, right? So you may have some lower disadvantaged communities that say, well, why are we being forced to drink this potable reuse water? That's not fair. Even though it's better quality than the other water, they may have an issue with this. And so, especially if those communities are near where the wastewater treatment plant, where the purified water plant gets located, they may be the first ones to get that drop. And so you have to be very careful. And we are working with some agencies that are saying, look, we know we cannot send as much water to the neighbor of the wastewater treatment plant because that will create a social equity issue. And so we know we have to distribute that water more equally and more equitably against all of our areas, or else that's going to cause an issue for us, right? So, you're thinking
It's a
about
tricky one, isn't it?
it's a tricky one. It's, the messaging to make sure it's clear that this water is such high quality. You also don't want to downgrade your own potable water. You don't want to
Right.
say how bad your potable water is. You want this water because that sounds so bad. Because then other people are going to say, well, why am I getting the bad water? I want the good water.
Reminds me of I remember years ago a Domino's pizza ad that was talking about the water for washing the dishes and how the water they were making their pizza dough with was so much better. And it was basically making potable water look really bad. And I thought, why are you doing that? So,
Interesting
yeah,
strategy. So
Yeah.
I just want to add a couple notes specific to Santa Monica in this project. So the majority of those new developments are actually potential affordable housing that was identified through our planning
Oh,
group.
Okay.
And so these were all identified. It was part of the regional housing needs assessment in California. So we're required to install 9,000 affordable housing units by
Well,
2029.
okay.
So it is serving mostly affordable properties by the time the system is fully built out. And the other side of this too, and how is messaged to our public action groups, our Commission on Sustainability, is that actually if we look towards direct potable reuse, the way that our system is set up is that all flow goes through the Arcadia water treatment plant. So in effect, if
Hmm.
we push a direct potable reuse program, that's actually the most equitable use of our water because everybody's going to drink that water, right?
So,
Nobody's going to be left behind.
gonna be a
Um,
blended, so everybody gets it. So
everybody gets it, right? Exactly. And they were really, they resonated with that message.
that makes sense. That makes sense. You're not picking winners or losers. Everybody gets the same. So that one.
Hmm.
Well, and so I will give an opportunity if there's any questions that are kind of over there from the QA. I looked like Dawn, occasionally you were typing. I don't want to, if there's anything on there that either of you wanted to grab and bring over to address for somebody, you're welcome to. Otherwise, the one I would like is to kind of wrap with is a little bit of speaking to next generation or folks looking for crossover careers or people who are in a water rich area looking to relocate to a water poor area. What kind of skills do they need to be an effective engineer or scientist as they relocate? So we'll speak a little bit to the educational one as kind of our wrap up. Were there any particular ones that were in there that we needed to address? I didn't see any that were burning questions, but I didn't want to leave you out in case you saw something there that you wanted to. I feel like
Yeah.
we've talked through a bunch of good stuff, but Alex, if you had anything or.
Yeah, I see a question from Ned regarding the potential squeamishness of using tap water that may have direct flow reuse in it. So I'll just share a story from when I presented this presentation to our Commission on Sustainability. And so it's a group of, they're council appointed members. Some are actual environmentalists, but they're lawyers, just regular public citizens, and it's also a public meeting. And so when I share the presentation, looking at the uses of these water, going through the highly treated multi-barrier treatment process that we have, comparing the water quality that we get out of this versus actually our own drinking water supply, and actually showing it, hey, it's actually of a better water quality than what we're getting at the taps right now. And this is even before we do the rest of the direct potable reuse program. So just SWIP as is already higher quality. And then you overlay the cost impact, you overlay the DEI equitability issue. And I heard from multiple commission members of saying, well, why aren't we doing DPR already?
Oh,
And boy, that was really encouraging to myself to say, okay, well, I did a great job on this presentation, but also the message is getting across of how viable this really is to the rest of the community. And so I think it's by pushing the multi-barrier process, it's showing that these treatment processes are really just mimicking Mother Nature, but just sped up a little bit, right?
mhm.
And that we've been drinking this water forever. So whether it's an environmental buffer or not, well, guess what? The whole environment for millions of years has been an environmental buffer. So those types of topics really resonate, and then you lay on the cost, the equitability. I think it all puts the pieces together.
It then sells from there. That's good. That's good. Dawn, anything you wanted to pick up from that? I just didn't want from that one or anything else from the chat and the Q&A because I didn't want to miss any. Folks that are also in your area that signed in to watch this, and I didn't want you to miss anything if there was something you wanted to pick up.
Peter asked about other regions in the U.S. doing recycled water. Again, I'd refer you to Water Reuse Association. It talks about all the different sections. What's really interesting is, California's been doing this for a while because of drought. The Pacific Northwest, it's starting to be a discharge compliance issue because of the fisheries in the area and then the Puget Sound and wanting to really make sure that things are really protected, right? On the East Coast, in New York, they're starting to do more reuse because of their stormwater systems are overwhelmed. So they need to find a better way to reuse the water to pull it out before it goes into to reduce the flows in their pipes because it's so expensive to build new pipes. Florida's been doing this ages. They've got both drought and discharge compliance because of the Everglades, right? So there's a whole lot of different reasons and areas that are doing this, and more Oklahoma is getting involved in reuse. You know, the Midwest, if you're east of the Rockies and you could be really shortage, Colorado is doing a lot of reuse. Interesting, when they start thinking about potable reuse, they can't do the reverse osmosis because they don't have anywhere to put the brine.
Right.
So they're using different treatment processes to assure that same high quality and protection of public health, and demonstrating that. And then I also put in the link to water360.com.au. That is this global water connections map where you can really go in, and they have little fact sheets, super interesting to play around in and see what's going on worldwide on that front. So
awesome. Thanks. So thoughts from the two of you, you know, how do people that are watching this as students or would-be students or recent graduates, you know, what would be advice you would have them in this space, or folks that are perhaps maybe they've been working in an area that was more water rich and now it's moving to an area that's more water poor, and they're thinking, well, what kind of skills do I need to bring in? Because obviously there's been plenty of folks in these regions working on these problems for many years. But there's also folks that come in that bring in new ideas and new perspectives and come in and kind of shake things up in a very good way, right? So what would be some of your advice for folks? And maybe Alex, maybe yours might cut a little bit more towards the, you know, you're gonna be with the utility, something like that. Maybe Dawn, maybe you cut a little bit more towards, you know, you're in the, you know, consultant space. You don't feel excluded to those, but that might just help the division of labor of answering the question. But
Sure. So my background was actually process engineer as a consultant, and then I came over to the public side. So I've, you know, about half and half at this point. You know, the really big difference for me now is I'm doing a lot more project management and stakeholder engagement and really answering to the public. So a really important skill set is honestly the soft skills. It's really being able to have, you know, tough conversations with individuals, listening, being able to take in information, the concerns of the constituents, resonate with it, not just immediately jumping with like, okay, here's the solution, let's run with it. It's then, you know, sitting on it, thinking about it, and then coming with an informed plan to really reassure the community that we're doing the right thing and in their best interests. So, I mean, there's lots of theoretical and technical things that are super important for this position, but it's honestly the soft skills that I use every single day that are super critical to working on the public agency side.
perfect, Alex. Thanks. Dawn?
And I've been in consulting all this my career, over 24 years now. What I really
Just a
love
few years,
is
right?
that what I really love is that consulting allows me to have my fingers in a lot of different pots. It allows me to work with a lot of different projects, different clients, visibility, research. I mean, all the different pieces. I think each individual, what you think, go with your strengths, right? So I'm an engineer by trade, but I like to think at 100,000 feet. So I got to know very quickly how to talk about things in very rounded numbers, you know, really high level estimates. Because as you see in this kind of a project, when you're looking at, you know, 20, 30 different alternatives, you cannot dig into the weeds of each of these. You'll never get to an answer. But you need that background in engineering to be able to support that, right? You need to understand basic hydraulics, basic financials, and that sort of things. So I think consulting is a great way to get a very wide array of project experience. I think a lot of our public agency clients that come from the consulting side bring a lot of value in that respect, having applied those projects and now looking at how do we apply it to the community basis. I'll say the same thing to Alex. One of the most important things is being able to succinctly document what you're doing, get decent writing skills. It's not poetry, but clear so that you can explain it to your grandma or you can explain it to your 12-year-old. That's really important what we do. Water is the livelihood for all of us. And I'll say to those thinking of coming in our industry, this is the best time to get into our industry. You will always have work, no matter where you move, to the largest city or the smallest little town. We need water to survive. It is the most important thing for this humanity, for the survival of the human species. We design these amazing infrastructures, but they don't last forever. They need to be re-envisioned. They need to be repaired. We need to plan better. We need to be innovative. I think the water problems in the next decades are going to get more and more interesting. And so we need more people coming into our industry. So come in, bring your friends, look around at all the options that are out there, and get involved. You really feel good about what you do at the end of the day. I'm not selling a widget, you know, I'm helping to make sure we have a sustainable future.
Oh, it's fantastic. Well, it's a no-brainer why you won the grand prize in planning. So Dawn, Alex, congratulations on that for the Excellence in Environmental Engineering and Science competition for 2024. So I think you may have one last trailer slide where we throw up at the end. I think, do you have that in your slide deck? You may have shut it down. That throws up so that people know what things they're looking for at the end. And then, yeah, again, Alex and Don, we so appreciate you taking time out of your busy schedules to be with us and the audience today and folks that'll be on the recording. And for those that are waiting, I guess, Marissa, will hand it off to you. It looks like Don's working on trying to get that slide up
I
for
am
you.
trying. And
Sure. Thanks, Dan. Thanks, everyone, for all your questions. And thank you to Dawn and Alex for sharing your knowledge with us today. We do have several webinars planned in the near future, so you can go to aaees.org/events, and you can reserve your spot there. Just a reminder, if you're not yet an AAES member and you're considering joining the Academy, please email me and we can discuss our membership options. PDH certificates for this event will be sent out shortly. That's all for now. We enjoyed being with you all today. Thank you so much and have a great day.
Thanks, everybody.
Thanks,
Thank you
everyone.
all.
Thanks,
Bye-bye.
Daniel. Thanks, Marissa. Great
Thank
presenting,
you.
Alex.
Likewise.